Hello everybody. Well, the test is tomorrow on Freefall, and I've already got a lot of the keys posted online in file form, but I thought maybe it might be helpful if I went through them in video form too. So this is going to be our extra practice. We've got questions 1, 2, and 3, and there's a couple different parts for each one. So let's get started. We have a ball here launched upwards at a velocity of 22 meters per second. You know, I'm going to write my name right here. There we go. 22 meters per second. So our initial velocity, VI, is 22 meters per second. And in part A, it's telling us that after 3 seconds has elapsed, so our delta T is 3 seconds, it's asking what is the height. So our displacement, our Y displacement, is what we're trying to find. And what else do we know about this? Well, we know that assuming this is on Earth, the acceleration is negative 9.81 meters per second squared. So what's our delta Y? Let's use our equation number 4. That is our equation for displacement, which is already in the form that we want because we're solving for Y. That's delta Y equals initial velocity times time plus 1/2 times acceleration times time squared. So our delta Y, our displacement, is going to be 22 times 3 seconds, 22 meters per second times 3 seconds, plus, I'm going to put 0.5 times negative 9.81 meters per second squared, times our time, which is 3 seconds squared. If we punch all that in, our displacement calculates out to be 21.9 meters. And again, all I did right here was I went down my list and found what I know, then found an equation that involves what I know and what I don't know, and simply solved for the unknown. So let's look at it's still number 1, part B, question B. What's the velocity after 3 seconds? Well, again, I'm going to write down my knowns. My initial velocity is 22 meters per second. The time equals 3 seconds. Acceleration is still the same, negative 9.81 meters per second squared. And the question is, what's the final velocity? That's what we don't know here. So it's final velocity. That is, it's not the final total, but it's the final after 3 seconds, which is what we're trying to find. So we have, let's use our first derived equation. That's our final velocity equals initial velocity plus acceleration times time. Again, this is already in the form that we're looking for because we're solving for final velocity. So let's just plug in our values. And for the sake of time right now, I'm going to not write in the units. I really recommend that you do. But to save a little time, I'm going to just write the value. So VF. So our VI is 22 plus negative 9.81 times our time, which is 3 seconds. Punch that into your calculator, and you should get negative 7.4. Negative 7.4 meters per second. And again, I know I harp on the putting your units in, but doing that will often enable you to put the right units for your answer. You want the correct units for your answer as well. So you know what? Heck with the time. I'm going to write my units in anyway because I just need to encourage good practices here. So I'm gonna put units back in. So part C, when does it reach its peak? That's a time question, right? So at what time does it reach its peak? We were just calculating what is happening with the velocity and position after 3 seconds, but this is at the peak. So at the peak, I'm going to write this here. At the peak of the ball thrown upwards, what's going on? Well, the velocity equals 0 meters per second. Now, I wrote VF as in final velocity, so because what that means is if we're just thinking about going from the ground up to the peak, that's the final. It's obviously not the total final because it's going to come back down, but we'll think of this as the final right now. The initial velocity, of course, is 22 meters per second. The acceleration is negative 9.81 meters per second squared. And the question is, when or what time does it reach its peak? So t is what we don't know. Well, that should be easy enough again, because we have our VF, our V initial, and our acceleration, and we can solve for time using the previous equation that we used. The issue with this, though, is that we need to understand that at the peak, we want to think of the final velocity right there, assuming the ball doesn't come back down, or the peak is the final position that we care about, that the final velocity is 0 meters per second. So let's solve for t. So if our VF equals initial velocity plus acceleration times time, then we're going to subtract the initial velocity from both sides and divide then by a. Well, I'll just write it out. Okay, and then divide by a. VF minus VI divided by a equals our time. So let's solve it over here. T equals our final velocity 0 meters per second minus initial velocity 22 meters per second divided by negative 9.81 meters per second squared. Punch that in, and we should get 2.24 meters. Not meters, right? 2.24 seconds, right? Again, there's the benefit of putting your units in, and it still didn't help me, but yeah, it should be in seconds. 2.24 seconds. And the final part of number 1 is, how high is the peak? How far does it go up? Our at the peak, final velocity is 0 meters per second. Initial velocity is 22 meters per second. What else do we know about this? The acceleration is still negative 9.81 meters per second squared. And do we know anything else? Not really. Oh, well, we know the time. We can write the time down too. Although, again, we want to avoid using it if possible, because we could have gotten it wrong in the previous problem. So let's just write down our time just for the heck of it. 2.24 meter. Or I keep writing meters. 2.24 seconds. If at all possible, again, let's try to solve it using just these knowns right here, because this could be wrong. So do we have an equation that solves for our y displacement but only uses final velocity, initial velocity, and acceleration to solve? Yeah, we do. We do. That's our equation number 5. That's our VF squared equals our VI squared plus 2 times acceleration times our displacement. So let's get our y all by itself here. Let's subtract the VI squared from both sides. So VF squared minus VI squared. And then I'm going to combine these two steps. Then we're going to divide by 2a to get our delta y, our displacement. So what's our VF? 0, right? 0 squared minus our VI, 22 meters per second. The value squared. So we're minusing, or we're subtracting that squared value, over 2 times negative 9.81 meters per second squared. That's our delta y. What do we get? 24.69 meters. If you calculate that through. There we go. That's number 1 of our review for the Chapter 3 Freefall test. I'll look for you on the next one. We'll do number 2 and 3 in separate videos. I'll see you then.